Now let's quickly write the Python code for arranging coins problem that we are discussing. So here I have defined the function also, right? So as part of the first check, what I will do is, if at all the coins that I'm getting is less than or equal to 0, in this case obviously we can't arrange the coins, right? So we can simply return 0 itself. If this is not the case, then we actually have got the positive number of coins. Now we need to find what is the last step till which we can arrange all the coins that we have got. So for that, since we are going to use binary searching technique, let me just define start. That basically represents the starting step, and that I'm going to initialize it with 0, and end, this I'm going to initialize it with number of coins that we have been given itself. Along with that, the middle, whatever middle step that we will calculate later on when we apply the binary searching, that I'm defining with middle and initializing with -1. Now we simply run a loop as long as the start is less than or equal to end. Here what we will do, first we will calculate the middle step, start plus end divided by 2. Once we calculate the middle, here there is a possibility to get the floating point number. So let's just import math, and from that math let's just do math.floor. Okay, once we have math.floor, we have got the middle step. Okay, now we have successfully calculated the middle step, right? And the next step is to calculate the total number of coins required till that middle step. And the problem statement clearly mentioned that for any ith step we need I number of coins. So to calculate the total number of coins consumed till this middle step is nothing but middle into middle plus 1 divided by 2. That is nothing but sum of the natural numbers, because first step will consume 1 coin, second step will consume 2 coins, right? So till second step the total number of coins is 3, and the third step requires 3 coins. So the total number of coins is 1 plus 2 plus 3. Till fourth step 1 plus 2 plus 3 plus 4. So this is nothing but sum of the natural numbers, which is calculated by using number into number plus 1 divided by 2. So the number here is middle. So here the total coins consumed will be is equal to middle into middle plus 1 divided by 2. So these are the total number of coins we need till that middle step. Now immediately what we will do, whatever the total coins that we've calculated is equal to the coins that we have got. In this case, all the coins are completely consumed till that middle step, so we don't have any more coins to go and arrange in the next step. That's the reason why here we will simply return middle itself. If this is not the case, if at all the total coins that we have calculated is greater than whatever the coins that we have got, so whatever the middle step that we have reached, at that point of time the total number of coins that we need is more than what we have. That means the complete step that we can fill will be from start till middle -1. So to continue that searching logic, here end step that we will do is we will update it with middle -1. If this is not the case, obviously what is the scenario? The total number of coins is less than what we still have. That means the step that we can fill still be available on the right part. To continue on the right part, we will simply update start with middle plus 1. Okay, so in this way we will calculate the middle, and till that middle step what are the total number of coins that we would be needing, and based on that, if it exactly matches, we would return that step. But if at all, even after filling this middle step, if we still remain some coins that that can partially fill the next row, the step that we have successfully filled till will be the last but one that we have successfully filled, right? I mean arranged the coins, right? So in this case what we will do, that step will be available inside this end variable whatever we are maintaining. So here we will simply return end itself. Till this end we have successfully arranged all the coins that we have got. Along with that, end plus 1 step has been filled partially with whatever the coins that have been remained. Okay, anyway, that is the way of calculating of arranging the coins using binary searching technique. Now let's just test it here. So the total number of coins that I have given are 5. So the first step will consume 1 coin, so we still have 4, and the second step will consume 2 coins, so totally we have consumed 3 and we still have 2 coins. And to arrange the third step completely, we need 3 coins, but we still have only 2. So the successfully arranging of the coins happened till second step only, because the third step is partially filled. So if I run this now, the output that I'm expecting is 2. That is what we have got. If at all, if I make it 6, third step can also be, arranged successfully. So the output should be 3. Okay. Anyway, if I give only 1 coin, with that 1 coin I can only arrange the first step. So output should be 1. Okay. If I pass any negative numbers or zeros or anything, ideally I am returning 0 itself, right? Because we can't fill any steps with that. So if I run this code now, the output is 0. Okay. So that is the solution for arranging the coins using binary searching technique, which basically finds the solution in order of log n time complexity, and the space complexity of it will be constant only. Okay, so that's it for this one. I'll see you in the next one.